be recording our conversations. All right, so Billy is not here today. He said, make sure you record and post. So everybody say hi to Billy.
Hi, Billy.
There you go. Yeah. So here's the thing. You say let's not quiz, let's just jump into the test, but we need a quiz sometimes for us to be able to have some understanding of, do we know what we know, right? We have a class activity today that I would like to count as a partner quiz. So I pick partners. So I think that's what we're going to do with more implicit differentiation today. And we're going to call this a partner activity, which is similar. I'm going to grade it as a quiz and make sure that you guys get the feedback that you need. And then that way we're, this unit 4 quiz and the higher order derivatives is then not on the religious observance day. And maybe we'll end up doing some kind of activity where you can get your feedback in class. That's the purpose of the quiz. Like, do you guys get that? So, and then we'll do our unit 4 review here on our higher order derivatives, I guess, and then your test. All right, so that's how our hour is changing. And then we'll talk about whether or not, and I'll come up with something for us to do and get feedback. Because what drives me crazy is if you make mistakes on the quiz and you don't get the chance to learn from those mistakes, then you're making the same mistakes on the test. So the purpose of a quiz is to give you a smaller kind of check-in to see if you're understanding what we're doing, and to give you feedback and let you make mistakes when the stakes are small, and that you fix those mistakes so you don't make them when the stakes are bigger. Without a quiz, that test is pretty dicey to roll into and be taking an assessment that's worth 60% of your, right, that test score, when it's averaged in. So, yeah, that's what we're going to do today. Yes?
So, there's a partner quiz today.
Yes.
And then a quiz on Friday.
Yes, and then I'll come up with an activity where you will be able to, it'll be a shorter quiz that'll give you your feedback so you know that before you take the test. Does that make sense? And then we'll have our review, our Unit 4 review is going to be on our Cultural Observance Day. So no assessments on that day. Sound okay? Everybody got it? All right. So like I said, that is on Schoology. If you made the changes to your purple paper, that's good, but we kind of got backed up with what we were doing. All right. So here we have our answers to our implicit differentiation. Hey, the biggest conversation about this is we're still just doing lots of taking the derivatives. Lots of conversations, and I put our poster back there where we have our tricky ones, but hopefully I want you to try to memorize them. I want you to, you should definitely know sine, cosine, you should definitely know ln, you should definitely know, e to the x, you should definitely have, if you need to peek for tangent and cotangent, me too sometimes when I'm out of the zone. But then we also need to keep in mind that everything folds into place, the power rule, the quotient rule, the product rule, and that's all part of the chain rule too. So it's one of those things, the more we practice, the better we get. All right, so what do you want to talk about for each of these? And here is your choice as a student. If you didn't do the work, copying down the answers doesn't do you any good. So, my recommendation is maybe writing down the answer only in the corner on another piece of paper so that you're not denying yourself of the opportunity to figure it out. For me, it's super important for you to know where all of these come from. So if I'm interacting with this key, my first thing is I'm going to understand, okay, do I get where this comes from? Yes. Do I get where this comes from? Do I know why this is there? And for me, that's going to be the most important part. The algebra that comes next about subtracting 10x from each side, dividing by 6y, you know, that algebra is secondary to understanding about taking each of those derivatives. Okay, let's look at sine of x plus y. Here we have the derivative of sine is cosine, and then I get, so there's a cosine of xy is a derivative. What is this here? What is that? Who can explain to me where that came from? Go ahead. Yeah, this is the chain rule. This is the chain rule. So our outside function is the cosine of something. Our inside function is x plus y. So when we have that inside-outside conversation, the chain rule says, go ahead and take the derivative of your outside. Keep this part the same. And then you need to then take the derivative of what's inside. Well, the derivative of x is 1. And I think that's a most missed problem. Kids forget, they think it's 1 and 1 times anything goes away. So you think, oh, I don't need to worry about it. But then when you're talking about an addition problem, that 1 counts. That is a 1 plus. And then the derivative of every y function is dy dx. The derivative of 2x is equal to 2. And now it's about untangling that dy dx. Finding a way to get this by itself. So you have to first identify, okay, what operation is happening here? It's being multiplied, so then I need to divide. And then what operation is happening? It's being added, so then I need to subtract, and that's how you get those values. When we look at 3, if you wanted to, true or false? If you wanted to, you could subtract 3, divide by 5, take the square root, and do the derivative the old-fashioned way. True or false? Can I solve for y? Yeah, you can. You can solve for y and then continue going. Having the derivative, having y isolated, if you wanted to, you can go ahead and say that y is equal to the square root of, what would that be? X squared minus 5 divide by, no, x squared minus 3. Divide by 5. If you wanted to, subtract 3, divide by 5, take the square root, you could do that. The square root is a big one. Or you can go ahead and take the derivative of each piece. With 4, when I take the derivative of 4x, I get 4. That's the easy part. When I take the derivative of 1, that's 0. Again, that's the easy part. The derivative of cosine is the opposite of sine. And again, here's our chain rule. Here's our inside function. So then I'm going to go ahead and take the derivative of that next. The derivative of y squared is 2y dy dx. The derivative of 5x squared is 10x. minus the derivative of e to any power is equal to e to that power. So that's like, it's exactly the same. It's crazy. That's one of those magical things about e. It's crazy. But I still have to honor the chain rule by recognizing this is the inside of my function. So then the derivative of that inside piece is 8y. And don't forget dy dx. Adrian, did I get to your question yet? You had a question where you're like, why is this way? When I was checking homework? No? Alright, let's talk about 6. Natural log of y squared puts y squared in the denominator when I take the derivative. Then I have to take the derivative of this function inside. So that's how I get 2y dy dx. If it's easier for you to think about this equation so you don't flub this up, you can think about this as the cosine of x squared. And you can do more chain rule. Or if you wanted to do the product rule, you could do that too. I saw some hands in here. What do you need? Did I get to it? What number, Grace?
So for 5,
Yeah?
I was a little checked out because when I compared my answer to the worksheet pages, the answer piece, it was completely different from what you're showing us right now. So it's like, can you just go over how to like solve number 5 a little bit more?
On the worksheet, it says 4y squared, and then on your projector screen it says 8y. So I think
When we did it together?
yeah, over here, it's just, I think it's just on the top, it's just 4y squared here, and then on the screen it's just 8y.
Oh, you know what? What you have on the worksheet is not right, and this has been updated. So this is correct. Because when we take the derivative of what's inside, it's not 4y squared, it's 8y. So what's on your key, she must have updated it. So she did the key, printed it out, and gave it to me. I'm like, oh, thanks for the key. And then I pulled up the key, and she must have done this with her class on Friday, and found a mistake and then fixed it. Because that's right, the 8y. Grace, does that clarify? Do you see why it's 8y?
Oh yeah, the 8y I get, but I don't get when you got that answer.
Oh, okay. So you want to know how to get dy dx by itself. Is that what you want? So you want to see the algebra?
Yeah.
Okay. All right, how do I do this? How do I get a new piece of paper to write on so that Billy can see it? Oh, there we go, right? Right? All right. So let me write on it so that you can see. All right. We're looking at number 5, right? Grace, were you okay with us taking the derivative, calling it 10x minus e to the 4y squared, and that's times, and we decided that the derivative of what's inside is 8y, right? dy dx, and that is equal to 0. Is that part okay, Grace? Okay. So I want to get this by itself. So I have to kind of pick apart what it is that I'm looking at. So this is one term, and this is a second term. This is all multiplication. E to this power times this times that. So this guy's got to go. first. Make sense? So if I subtract 10x from each side, I've got the opposite of e to the 4y squared times 8y times dy dx is equal to the opposite of 10x. So now what I'm going to do is, since I need to get this by itself, and everything here is one term, right, that's being multiplied, I'm just going to divide by whatever I want to get rid of. Negative e 4y squared times 8y. So on this side, this all cancels out, right? And I end up with my dy dx is equal to, so let's talk about what cancels out here. These two negatives cancel out. And this 10 and this 8 are friendly numbers, so I'm going to take a 2 out. And that's going to give me, in my numerator, I'm going to have 5x. In my denominator, 4y. And then I can't forget about times e to the 4y squared. Does that look familiar?
Yeah.
So honestly, if somebody ever watched me do my homework, they'd think I was a crazy person. Well, people think I'm crazy anyway. But when doing my homework, I talk to myself because I want to make sure I don't make any of these classic mistakes. I need to go back and tell the difference between what is being added, what is subtracted, what is a factor, what is being multiplied, what is divided. Because I'm not going to spend all this time learning calculus and then make an algebra 1 mistake. Like, that's infuriating to me. If I'm capable of doing calculus and I'm going to lose points on a quiz, take the points off of the calculus, not the algebra 1. That drives me crazy when I drop negatives and do stupid stuff. So I wind up talking to myself to make sure. And I'm telling you what, at this level of math, we're all screwing up left and right. I mean that's obvious when she made her key. We 1 minute our brain goes sideways and we're like, oh snap, I totally missed it. So we just want to make sure that you're careful when you're going through. And that's why if I give you a partner quiz today, you guys can talk to each other and then work that out. Okay. So 7 and 8, the derivative of sine is cosine. Little chain rule happening there. And then e to the y, don't forget your dy dx. And these are the fun ones. These are when I have two dy dx's, and that's always going to be a part of factoring. So that's always going to be, hey, factor that out. And that's going to give you, and there's lots of simplifying that's happening with, friendly numbers every chance I get. 8, we okay there? 9, 3 to the, so we repeat that, and then the natural log of the base, and then the derivative of what's inside of that inside function. The derivative of sine is cosine, x squared, and then we have the chain rule again. So we've got the chain rule 3 times for number 9. Number 10, this 8 comes out as as a coefficient, and then chain rule, take the derivative of what's inside. And these ones are not implicit differentiation because if you notice, y is already solved for. So this is, if you take the derivative of this, you're doing it explicitly. These functions also explicit. My quotient rule, And this one's hard because it's the quotient rule and the product rule. Check that out. Because when I take the derivative of that numerator and when I take the derivative of that denominator, we have to be smart. And we start mixing it in together. So these ones keep in mind. And I know we had some conversations about notations when I returned the tests, but it's super important when now that we're bouncing back and forth between implicit and explicit differentiation that you let everybody know what it is you're doing. Here's the derivative. Now when you're talking about your explicit, notice that that notation's there. When we talk about explicit, we communicate that through having dy dx in our problem. So when you just dive in and you're taking the derivative, that dy dx is what you're communicating. Hey, this is what I'm doing. Sound okay? Okay. So, for those of you that did the homework, thank you. For those of you that didn't do the homework, you're missing out on some critical practice. You don't want the first time that you're doing this work to be when you're in an assessment situation. It's too hard. It's too confusing. And it's too easy to sing along with the radio. It's too easy to just copy down what either your partners or your table mates are saying. So what we need to make sure that we're doing is putting our own brain cells into the work. Alright. So the good news is today's lesson is more of the same thing. The bad news is today's lesson is more of the same thing. So with today, we're looking at just more implicit differentiation, more conversations about how to take the derivative and what happens with each new level that we're working on. Does yours match mine? Are we looking at the same thing? All right. Review. An implicit function is a function where one of the variables is not explicitly written as a function of the other. Every time you see y in your equation, you have a function in disguise. The derivative of y or y of x is equal to dy dx, i.e. the instantaneous rate of change. If it's easier for you to write down what you can talk about as an explicit function, give yourself a note that an explicit function is when it's written as y is equal to. Now, if you have the ability to solve for y and then take the derivative, you can. It doesn't matter what order you do your work in. We have to have implicit functions because sometimes we can't untangle y. Sometimes we can't solve for y. If you look here, we can't get y out of there. We can't get y out of there. So what we end up doing is just taking the derivative, and then we can work on untangling the dy dx. We can work on untangling that after we get that derivative. And it's kind of nice because the derivative takes us down one level. And by going back down one level, sometimes we end up eliminating some of our exponents or something like that. All right. So with your group mates, go ahead and tackle example 1. And I want you to have a conversation. I want you walking through and making sure that everyone's got it covered. On your mark and set, go. It's so fun. Take a look at number 1. Did you miss the product rule with 4x times y? Yeah. And that's going to be one of those, oh. Yes.
Why does it equal 0 and not 10?
Because I took the derivative of a constant, and the derivative of a constant is 0.
Oh, okay.
Yep. Go ahead.
I'm confused on like how the product rule would work there because you could rewrite that as like x 4y.
So the interesting thing is the product rule, and this is what Nadia, Grace, and I were talking about. The product rule comes in so many different formats because of the commutative property. So if you look over here, I summarized the product rule for us. Hold on. Stop. It's not behaving. I summarized the product rule for us, right? The problem with the product rule is that it's all commutative. So both of these multiplications are commutative, and the addition is commutative, meaning you can do it in any order you want. And I was telling Nadia, I cheat sometimes. I look ahead and my brain twists things so that I make sure I have like a coefficient or something first. So if I do things in an order that feels like, wait, what? That's why. Like I'm horribly inconsistent with the order that I do the product rule. Miss R has already yelled at me. She's like, Tracy, you can't do that. It confuses the kids. I'm like, or it teaches them the commutative property. Like, I don't know. Call it what you want. If h of x is equal to f times g of x, it's one function times the derivative of the other plus the other function times the derivative of the other. So if you look at 4x, do you see here in blue, I put my 4 with my x? That's the coefficient. I have a choice. I can pull that coefficient out, do x times y, and then multiply everything by 4. Or I can just recognize that I'm just going to group the 4 with the x as a coefficient because I know how to take that derivative. So here's my first term times the derivative of my second, and because it's a y, it's dy dx, plus, and Nadia's question is, why is that a y and not dy dx? Well, because that's my second term. That's this plane of g. So if you followed this order, you might have called that y times 4. I stuck the 4 out in front because I know it's going to be a coefficient to y. So this 4 is the derivative of 4x. This y is just that other factor. So that's my product rule here. Here, 2y dy dx is equal to the derivative of my y squared, and then 0 is just 0, because the derivative of that constant. And then what I do is I highlight, when I'm doing this, I highlight all my dy dx's, because my job is to get them on the other side, on the same side. Everything that's not a dy dx, he can go. Goodbye, see you later, I don't want you. You're in the wrong spot, move. So my 2x's got to go, my 4y's got to go. And when I'm left with this, I can then factor my dy dx's out. And then we're down to finding a common factor that we can pull out to simplify. Sound okay? Yeah? All right. So we'll do the next one. Ready? I'm sitting here. Are you ready for the next one? Say yes, like you mean it.
Yes.
What rule do you see happening here? All right, so when I have the quotient rule, we're going to go ahead and say that the derivative of this quotient, are you going to sing with me or are you going to be sing by myself? I love it. So my low is my sine of y. D high, what is the derivative of x? Low d high minus, and then I'm going to say high And then what is the derivative of my low? Square the bottom and away we go. Now, if you wanna say it's sine y squared, you can. If you wanna instead rewrite it as the sine squared of y, we don't say sine of y squared because that's confusing, right? It's not the sine of y squared, it's the sine of y squared, which is why that 2 goes in there. Square the bottom and away we go. And what are we doing over here? Where's our dy dx? Oh, we missed it. So if you don't have a dy dx, go back because you missed it. Low d high minus high what? D low. So the cosine of y, the derivative of that, and then the cosine of what's inside is my, right? There's my dy dx. All right. Are you suspicious about that equals 0? So, all right, let's go ahead and multiply side by sine squared y. What are we excited about? Okay, so the sine of y minus x times the cosine of y times dy dx is equal to 0. And just to keep everything positive, I'm going to add this term to both sides. Oops. Did you see what I did? I added that to both sides. Here's my dy dx, here's my dy dx. So now I'm going to what? So the sine of y over x times the cosine of y is equal to, these guys end up canceling out, my dy dx. Yeah,
So why is it that when you take derivative of sine of y, why is that cosine y times
because that's my cosine rule. The, when I take my derivative, sine of y, I get cosine. I use that one.
You didn't have stuff in the stuff. So you either have to do this, like, silly to do this in this. Yeah.
So you were taking this bad, is it like sine of x?
1.7.
But when we think about that embedded function.
Wait, we have this R, right? There's only one. I kind of felt good. It was pretty quick. Actually, that
it was pretty good. I got third.
Oh, no, I think we should split up. And then it was also hard. The math was so hard. Let's just say, what's talking about? Who's you in it?
You're gonna be there for Saturday.
I just think they canceled out for now. That means in the sun like the 15 at the bottom, right?
Right?
I'm just waiting for my back to stay back field, and it's still pretty much feeling
She lost the notation. She still had a great birthday, but it's not enough for her. And she didn't do notation right, and she started doing this.
If you go back to the notes, she
No, like,
has
says it,
written,
yeah,
Right, so why, think about that in bed before you mind that.
Yeah, and it's like, yeah, because Jimmy called her over and he was talking like Jimmy was offensive like that. And then she was like, yeah, she got offensive and then she got mad and then she got
So
crying.
think chain roll, gotta take the.
And then like, and then I go over my desk by 60. I wish I had 80.
Right.
That's fine with the class.
But because there's a law in there, that's.
Yeah, I actually do. If I didn't do this class, I
Are you already talking about example 3?
Yes.
We have a question on number 2.
Go ahead.
What happens to the sine y, the sine squared y on the
So
bottom?
much thinking to know.
Oh, snap. I forgot about it. Simon, go put a Smartie up. Ready? Hold on. I have to get rid of that. I don't know how I just did that, but it's gone. Because. Oh, wait a minute. I did take care of. I multiplied each side by it. Simon. I was right.
Minus one smarty.
No. Did he already draw it?
No, I didn't.
You need to be faster, Smarty brother. Then I would have kept this.
That's close.
Whoa.
No, you
I saw this time.
I also love this. Start talking, and we'd start erasing Smarty.
Stop. Here we get to 0.
Okay, ready?
I have better grades.
If you multiply both sides by it.
All right, ready? Natural log. Now, let's talk about this. You're freaked out by these, but don't be. Because look, the natural log of x, that's 1. And then here, so we are definitely using what? Your product rule. Okay. Go. One thing I wanted to show you when I looked back at my key that I did before, I simplified sine over cosine as tangent. So I would still accept this answer. But if any of you recognize sine over cosine as tangent, rock on. Sound okay? Yeah, sine y, cosine y. Definitely tangent. All right. So these are fun conversations that we want to make sure that, and it's putting it all together and making sure that you understand what it is that we're asking for you. It says, find the slope of the tangent line of the function at this point. So I know that the slope of the tangent line of a function is the derivative. So I'm going to find the derivative. And what's interesting is, do you see how I have this y that's embedded? So I'm going to use implicit differentiation. So in my answer, I'm going to have both x's and y's and dy dx's, right? So when I go to find the slope of the tangent line of the function at that point, I'm not plugging in just x's anymore. I'm plugging in that y too. So we want to kind of remember that as we move on. All right, let's do example 4 together so you understand what it is that you're doing. When we find the slope of the tangent line, we know that that means that you're asked to find the derivative. Oops. So that's our derivative. So we're going to go ahead and say 2 is equal to 3x to the 4th plus x times y to the 4th. Before you jump in, do you ask yourself, power rule, product rule, quotient rule, chain rule? Those are your ones you got to watch out for. What do you see? I don't see a chain rule. What do you see? There's a product rule in there. So whenever I take the derivative of a constant, I get 0, right? This is going to be 12x to the 3rd plus Now, if it helps you to color code, here's your first and here's your second. And I don't care how you do it, because with the product rule, everything's commutative, multiplication and addition. So I'm going to go ahead, here's my first factor times the derivative of my second factor, 4y cubed, what do I do? dy dx. And then it's going to be plus, the derivative of my first term is 1. And then my second term is just going to be y to the 4th. So here's my power rule, 4 times 3, 12x cubed. Here's my product rule. Here's my first term, derivative of the second, plus derivative of the first times my second. All right, so then when I go to simplify, put all this stuff together, I get 0 is equal to 12x cubed plus, this is going to be 4xy cubed, and that's where my dy dx is, embedded in this term as a factor, and then plus y to the 4th. So I'm going to go ahead and subtract this from both sides. Minus 4xy cubed times dy dx is going to be equal to 12x cubed plus 4xy cubed plus y to the 4th. Then when I divide by my negative 4xy cubed, I get my dy dx, the slope of my tangent line of this equation at any given point. Now let's see, I can't factor anything out because I've got x is here and here but not here. I've got y's here and here but not here. I've got a common factor, 12 and 4, but not there, so it looks like I'm stuck. I'm no chance of simplifying. Where did I lose you? Speak up.
Shouldn't there not be a 4xy to the third in the numerator, in the purple? Because you said the other side? Yeah, it's on the other side.
What did I do that for? Jeez Louise. So this, hold on. So 12x squared, I subtracted that, plus y to the 4th. Isn't that nicer? Times negative 4xy cubed. Now am I good? Was that you, Catherine? Go ahead. Dy dx. I still don't have anything that cancels out, right? So 12x cubed plus y to the 4th over minus 4xy cubed. Now what? That's my point. So the slope of my tangent line at any given point is equal to this x and this y. It's for that point. So 12 times my negative 1 cubed plus y to the 4th over negative 4 times x, which is negative 1, times y, which is 1 cubed. So that's going to be negative 12 plus 1 over positive 4. Negative 11 fourths is the slope of the tangent line of that function at that point. The next conversation that they ask you to do is find the equation of the tangent line. So my next step, if they had asked me to find the equation, here's the slope, here's the point, so I'm plugging it into point slope form. And that's gonna be a huge conversation. Ready to go for 5? Examine it. Say hello to the function. Ask, all right, what do we got going on here? We've got x as one factor, the sine of 2y. Watch out for the chain rule on that one, right? I've got y as another factor, the cosine of 2x, and then I got to plug this point in once I find. In order to write the equation of the tangent line, I need 2 things. I need a slope and an xy ordered pair. So it looks like I got to go find that slope, right? Going to take the derivative. Double product rule. Are you ready?
No.
Come on, we can do this. Seriously? What's it, like 10 Smarties left? I could make 10 mistakes on this. So tune in. Ready? Here we go. Product rule. My first times the derivative of my second. Cosine of 2y times the derivative of what's inside, 2 dy dx, plus the derivative of my first. The derivative of my first is 1 times my second, which is the sine of 2y. Are we good so far? All right, so now we'll come back here and say my first term is y times the derivative of what's inside. The derivative of cosine is negative sine of 2x times the derivative of what's inside. And I don't need to worry about, I'm going to do this. Don't need to worry about dx, right? Plus the derivative of my first, which is dy dx, times my second, which is the cosine of 2x.
Where is that 2 coming from? Inside the
That is the derivative of what's inside. Chain rule. Yeah. I always forget that too. I'm so proud of myself that I didn't. All right. So now when we go to put this together, we've got 2x cosine 2y dy dx. That's confusing. Let's write it better. Ready? It's 2x is together, and then it's easier if we keep cosine of 2y together, and then have the dy dx. Those parentheses help out a little bit, don't they? So here's my 2, here's my x, cosine of 2y, dy dx. All right, and then this is going to be plus the sine of 2y is equal to, I'm bringing that 2 out and buddying him up with the y, and then this is still the opposite of the sine of 2x, plus, and then I'm going to talk about the cosine of 2x, but then here's my dy dx. I'm going to go get my highlighter because this guy's got to get with this guy. So 2x cosine of 2y times dy dx. He's staying. Minus 2y is leaving. and minus cosine 2x dy dx. I subtracted this guy and brought him over. Are you guys okay with that? So I subtracted him. 2y times the opposite of sine of 2x, and then this is minus that sine of 2y that I subtracted here. So you know what we're going to do, right? See these guys here? What are we doing? Come on, call it out. Use the F word. Factor. It's the F word of algebra. Two x cosine of 2y minus the cosine of 2x. 2y times the opposite of the sine of 2x minus the sine of 2y. Now it's time to divide. Divide by this entire thing, divide by this entire thing. So there's nothing I can cancel out. Nothing's pretty, y'all. So we have to start substituting our x and our y. See them over here? Take a deep breath. We can do this. 2 times y, which is pi over 2, times the opposite of the sine of 2 times x, which is pi over 4. Minus the sine of 2 times y, which is pi over 2. All of that divided by 2 times x, which is pi over 4, times the cosine of twice y, which is pi over 2. Don't give up. I heard you drop that pencil. Minus the cosine of 2 times x, which is pi over 4. And look, we have all this space to keep going. Hip, hip. dy dx is equal to, all right, so let's just take this one at a time. So 2 times pi over 2 is equal to pi, right? Times 2 times pi over 4 is pi over 2. The sine of pi over 2, everybody think about where it is on the circle. A pi, its sign is positive 1. So I want the opposite of that. Negative 1. Did you follow that? Pi over 2, think about it where it is on a circle, right? Pi over 2 up top. Cosine 0, sine 1. But I want the opposite of that. Okay. Minus the sine of 2 times pi over 2. 2 times pi over 2 is pi. What's the sign? 0, right? The sign of pi, picture where it is in a circle. It's right over there, over by Caitlin. So minus 0. Look how easy that is all of a sudden. What is 2 times pi over 4? That sounds like pi over 2 times. All right, the cosine of 2 times pi over 2. 2 times pi over 2 is pi. So it's the cosine of pi. -1, you got it. Minus, okay, 2 times pi over 4 is pi over 2. What's the cosine? 0. What? My negatives cancel out. dy dx is equal to pi divided by pi over 2. That looks like this, pi divided by, I still have to do this sometimes to make sure that I'm not screwing it up. Pi times 2 pi, what? You're like, 2? All that for 2? Nate comes back. The answer's 2.
The answer's 2. I got it.
After all of that, what? The answer's 2. Hey, we're not done. We're not done. We're not done. What did they want us to do? Who remembers? Go read the directions. What is this formula called? It is your best friend because we accept things in point slope form. So y minus, what was y1? Pi over 2. Right? Is equal to your slope we just found here. We'll do that in purple. Times x minus, what is x1? So I have, and that's a good answer. If you wanted to put it in the slope-intercept form, because remember, it's equation of tangent line. We can solve for y, write it as a linear function. So that's 2 times x minus pi over 2, and then this is plus pi over 2. What? How's that for algebra 1? All right. So that's the notes. Here's the good news. We made it through the notes today. Here's the bad news. No partner activity.
That's good news.
So excited.
Turn around and goes, you guys seem so sad, let's do it.
No, we don't have time. But now I gotta figure out where your homework is. I swear I ran it off.
No break.
Hey, I wonder if it's still in the